Kinetic energy is a motion energy that would exist only if objects are in motion. An object of mass m moving with a speed v has a kinetic energy that is given by the following expression. Ke, K stands for kinetic, E for energy, equals 1/2. M is the mass of the object, V is the speed of the object. Notice that the kinetic energy is directly proportional to the mass, which means if the mass increases by a factor of 2, doubles, the kinetic energy will also double. However, the kinetic energy is related to the square of the speed, which means if the speed is doubled, the kinetic energy is going to quadruple. That is quadratic relationship between kinetic energy and speed. The speed is more significant than the mass in this case. Gravitational potential energy is an energy that is acquired by a mass m when it is placed in a space where there is gravity. The mathematical expression for the potential energy is given by the following expression. Pe, where P stands for potential, E for energy, equals m, the mass of the object, g, the gravity, h is the height. H is the height of the object as measured from some reference point, which is arbitrarily chosen. For that reason, the potential energy doesn't have that physical meaning because it varies as we change the reference point of measurement. The quantity that has physical meaning, and it's always the same regardless of the reference point of measurement, is the change in potential energy. To prove that, let us have the following example. An object lifted from the ground to the top of the table. Here is an example where a mass m is lifted from the ground, this is initial right here, and is going to be placed on top of a table right here. Case number 1, we're going to assume the height 0 is going to be the ground. This is h equals 0. Therefore, this one will have a height h, which is the final. Let us evaluate the change in potential in this case. Delta PE equals final minus initial. Remember, delta always means the change, final minus initial. Alright, the final is where the object is on the table, is the mass of the object, gravity, height final, which is h, minus mgh initial. mgh initial is the 0. Therefore, the delta PE, let me keep writing down here, the delta PE is going to equal mgh minus 0. The answer is mgh. Alright, this is case 1, where the height 0, or the reference point of measurement, is the ground. Case number 2, I'm going to use the reference point of measurement, the height equals 0, to be the top of the table. h0 is here, and therefore the ground in this case is going to be the negative h, because it's below the 0. Clear? Alright, let us evaluate the delta PE in this case. Delta PE equal mgh final, which is PE final minus PE initial. Okay, the final is the top of the table, which is mg, what's the height there, is 0, isn't it? Minus PE initial is where the ground is. mg, what's the height when the block is on the ground, is negative h. Therefore, the delta PE is going to equal 0 minus mg times negative h, that gives you positive mgh. The answer therefore is delta PE is going to equal mgh like before. This is case 2, which is the same as 1. The conclusion is the quantity that gives good physical meaning to the potential energy is the difference in potential, the change in potential, and that is the reason why all the laws that you're gonna see are delta P related.